Okay, so we're going to start here with solving linear systems by graphing. We're going to do very simple ones. Next year, you're going to do more complicated ones, but for now, let's do this. So when it says solve by graphing, here's what it means. It means graph these two lines and see where they meet. This is it. Graph the two lines, see where they meet. Now, here's the thing. If the lines are parallel, there will be no solution because they don't meet. But usually the lines aren't parallel. We find out that they meet somewhere, and that is the solution. So first, we're going to label our graphs 1 and 2. Then we're going to graph them. So to graph, again, if this is challenging for you, watch this. Then play it again and do it with me. If you're okay to just go straight and do it with me, then you do that. So the first step is plot the y-intercept, +1, make a point. Then rise and run from that point to another point. So 2 is the same as 2 over 1. So I'm going to rise 2 and run 1. And it's positive. So I went from here, rise 2, run 1. And got the old connect the dots routine. So that is, we always, like as in every time, put the equation of a line near the line. If it's a curve, which you will do in later years, you will put the equation of the curve beside the curve. Okay, now we're going to go to this one. Y-intercept is -2. You don't have to make the points as big as me. I just do it to accentuate for you. And then we're going to, this slope is 1. So I'm going to rise 1, run 1. I'm just going to, now let's say you have a situation like this where your lines don't meet. You can see that this line is going to meet. So what you do is you just erase your little arrow and you continue with the slope. So over 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2, and that's where they meet. Okay? You will, as long as you can continue using your rise and run, you can continue your line so that accurately you can find, not like, oh, it looks like it's over there, and you accidentally pick this one or this one or this one when it's this one. Okay, so what is the solution? The solution is where they meet, and this is the way we write it. We write x, y. Okay, we write x, y equals, and then what's the x of this point and the y? -1, -2, -3. And then -1, -2, -3, -4, -5. Okay, that's the solution. That's how you solve by graphing. So basically, what I want you to understand here is that this point -3, -5 is on this line, and it's on this line. And you can always check to see if something is on a line by taking the x and y value, plugging it into the equation, and seeing if it makes the left side equal the right side when you do that. Okay, so let me just check that this is a point on this line, just to show you a check, even though we've done them before, but we haven't done one with this question. So check. So left side equals y, right side equals x minus 2, correct? So y is -5, and x is -3 minus 2, which is -5. Therefore, left side equals right side. Therefore, -3, -5 is a point on the line y equals x minus 2. If you wanted, you could check the other one. You don't have to because the question doesn't ask you to, but that's how you do it.